So as I mentioned in a recent video, one of the things I added to Mission Control is this ability to create sandboxes directly from the user interface. Now, for the most part, this is working great. It'll go to my AWS account, it'll create an EC2 instance, but it is a little slow. And the reason it's slow is because every time you create an EC2 instance, you have to not only create the instance, but you have to run a user data bootstrap script that installs Claude Code, has to install Open Code, and all these other tools that need to live on the machine so that we can actually connect to it over WebSockets when I run Mission Control locally. This is basically going to set up a WebSocket and communicate with this agent living on the machine. So you can imagine this takes some time to create all this infrastructure and then to install the dependencies on it. And then also every single time you create a new sandbox, it could potentially be a little bit different, right? We are probably installing the latest version of Claude Code, the latest version of Codex. And so you're not guaranteed a repeatable sandbox every time you deploy. So one way I wanted to circumvent the version dependencies changing every install and also to make it run a little bit faster is that I decided to go with a pre-built image approach. So one of the tools you can use if you kind of dive into AWS and DevOps is something called Packer. This is a tool provided by HashiCorp. It's a very, very useful tool where basically you can configure an EC2 instance, what should live on it, and then when you run it, it's going to go and create an EC2 instance on your AWS account. It starts to initialize it, it provisions it, and then it's going to create an actual snapshot of that instance. With Packer, it kind of automates this whole process, and it also allows you to publish it so that other people can use it. So not only do I have access to use a snapshot, but other people using Mission Control can use that exact same pre-built image. Now, the one thing I'll point out is that when you're setting up this type of approach for users, you want to make sure that the images and also the setup scripts are publicly available so that people can see exactly how this stuff is kind of set up. So I do have a public repo called MC Sandbox, which has the Packer scripts and it also has the install scripts, and you can kind of view it to verify that the image that was built up does only install the things that you'd expect it to install, okay? So I would recommend you would go through this install script, you run it through AI, make sure it doesn't have any security issues, it doesn't install malicious code. But for the most part, this runs once when we're trying to actually build the AIM image. It's going to install the latest version of Claude Code and Codex, and that gets created and bundled into the AIM image when I basically run a tag. So over here, there's a GitHub action that runs when I do a tag, and that is going to go through that whole process of running Packer, doing the install scripts, pausing the instance, creating a snapshot so that other people can use it. And then eventually I do have to publish out a manifest file so that Mission Control knows what is the latest version of this AIM. Because I could be publishing new versions, adding in support for new CLI tools, but Mission Control is just hard-coded to basically just grab the latest AIM image from my repository and kind of install that. Now, I did want to walk through a little bit of how this kind of works. So when I tag a release on that repo, like I mentioned, it kicks off a GitHub action, and it eventually calls a build AIM MJS script. And if you look through the code, all this does is basically use this definition file, and this says what region the AMI image should live in, also the instance size of the image, the architecture, if I want to use Ubuntu or something else, so that it knows what type of EC2 instance to initially create. And then we can actually dive into the contents of the script. You'll see here build AMI MJS orchestrator. It verifies a couple things, like it makes sure that the install sh script is there. It makes sure I can connect to AWS. And then it runs Packer init, and then it runs Packer build. So Packer build's where the cool stuff kind of happens. This is going to automatically spin up the instance that you desired, right? It's going to spin up a T3 medium because that's what's defined in this Packer config somewhere. I think it was defined up here. And then it's going to wait for it to be fully ready. And then it tries to install all those dependencies using the install sh script, like I mentioned. So installing Claude Code and Codex. It's going to go through and make sure it scrubs all and any sensitive things from the machine, such as logs or security keys, etc. And then eventually it creates an EBS snapshot again. So it's going to look at that running instance, it creates a snapshot, and then it copies that AMI image to various different regions so that you can spin up the same snapshot in West or West 2 or East 2. And then I make it public so that everyone else can see it. Now, I think at this point, everyone could potentially use the AIM image. But the question is how do I get Mission Control to know about what is the latest image? Because I could be publishing new versions and updates and installing new CLI tools. And so what happens is I build and publish this Packer manifest JSON, and that goes directly to this Mission Control. So on my hosted website, I do have a manifest JSON file that people can go and download. And that tells Mission Control where the AMI image is, what's the latest version, etc. And that's kind of what's happening over here. So when I go to create a public sandbox and I say from a pre-built image, I'll just say testing and I kick this one off. Again, that's doing that whole process of figuring out what is the latest version of the sandbox image that I need. And then you'll see that's going to go through and create an EC2 instance that we can actually use. If I go over AWS, that is spinning up as we speak. And the cool thing about the AMI snapshot is that it's a lot faster than the setup script every time, right? Everything's ready to go. This takes about 30 seconds to maybe a minute for it to be fully online. Like you can see here, it's already running. If I go back to here, it will take some time. It's not faster than using something like Firecracker, but I do think just having an EC2 instance that you can have full control over is a pretty nice way to have like a workspace. Okay, now it's ready. I can actually go into the sandbox now. I do have code to automatically copy over your permissions so that the Git repo you're trying to work on gets cloned automatically. And then also your Claude Code credentials get sent over to the machine as well, so that you don't have to go and re-authenticate Claude Code and Codex every single time. Okay, so yep, I'll say trust the folder. I'll say accept. And now I can actually just say like, let's say hi and see if this actually responds to me. Okay, so hi. Cool, so that's all working. At some point, if you don't want to actually work on the sandbox anymore, I did set up a 30-minute idle timer. So like when you don't actually communicate with Claude Code or the actual sandbox itself, like I mentioned, there is an agent running on this machine. And if it doesn't have activity within 30 minutes, it just pauses the whole EC2 instance. So that's one way that we are reducing running costs with people who are using the sandboxes. Now, you might ask, like, why would I even go through this effort of adding sandboxes? Again, there's a security concern with these agents running on your local machine, having access to your complete file system, and having this stuff run in the cloud in a sandbox or a workspace is a little bit safer. But not only that, is that sometimes you want to kick off a very, very long running task. Like you want to ask Claude Code to implement a whole refactoring on your code base, and that could take up to 30 minutes to an hour, maybe even 2 hours. I've seen these things take a very long time to do things. And so having this run in a sandbox where you can go and then close your laptop and come back later has been very beneficial. I can actually create a couple of sandboxes. I can have them all doing their own large refactorings, and I can tell them to commit and push and create a pull request when it's done. And then when that all finishes, the sandbox just pauses for me automatically. And then I come back the next day and I have, you know, those pull requests with a ton of file changes that I can then review and merge into main. So I think that's all I really wanted to talk about here. I'm gonna go ahead and just pause that sandbox, and we can go back to EC2 and you'll see that it is actually in a pausing state now, and that'll save me some money. So if you guys enjoyed this overview of Packer and how this kind of all works, let me know. I think there's more stuff I can probably talk about in terms of the MC agent. I think this is some pretty cool stuff as well. Other than that, have a good day. Happy coding.